Hello everyone, welcome to Pre-Calculus Algebra. We're going to start our course with a review from your college algebra about one of the most important functions. It's called the quadratic function. Alright, so first of all, let me start with the definition. Number one, definition. A quadratic function is a function that looks like this. F of x equal to ax squared plus bx plus c. First of all, let's just box it. In here, x of course is a variable, okay? A, B, C's are numbers. We call them the coefficient. A, get a better marker. B and C are coefficients. It's just numbers, alright? Where A right here, the number in front of x squared is called the leading coefficient. Okay? And we have one condition for the leading coefficient. This number A needs to be non-zero. You guys see why? If A is equal to 0, I'm not sure if you guys can see it because the marker is out of green, so let me just erase it, rewrite it. A gotta be non-zero. Because if A equals to 0, we don't have x squared term anymore. It becomes bx plus c, which is the linear function, which is a straight line, not quadratic anymore. And by the way, this is a review, so I hope that you're all familiar with this. Okay? So let me give you some examples. Say I got f of x equal to 3x squared minus 5x plus 1. This is quadratic function where a is 3, b is negative 5, and c is 1. Okay? Or how about another one? F of x is equal to negative x squared plus 2. So a is negative 1. But we don't have b term. We don't have the x term, so b is 0. And c is 2. We only need the a term to be non-zero, but b and c, they could be 0. Okay, so basically this is the definition of quadratic function. Okay, we have three terms: the x squared terms, the x term, and the number term. Right? Now let's move on. I'm going to show you some basic properties of quadratic function. Some properties. The first one, we'll talk about the graph. The graph of quadratic function, we call it a parabola. How does a parabola look like? It could be either open upward or open downwards as functions. Okay? And the orientation of the parabola, either upward, being upward or being downward, depends on the sign of the number a, the leading coefficient. If you have a as a positive number, positive leading coefficient, the parabola is going to open upward. And of course, the other case is a negative number, the parabola will be open downward. Of course, a has never been 0, so we don't have that case, a equal to 0. Okay? And actually, there's a lot of applications about parabola you guys may have seen before. If parabola is open upward, then we're going to have the lowest point on the graph, and this is going to be the minimum. It's open downward, we're going to have this like a mountain, right? This is the top of the mountain. We're going to have a maximum. We're going to be talking about this a little bit more when we move on to the next item. Next, we talk about the second properties of parabola. I'll be talking about something called the vertex. Okay. Number 2. Property number 2, vertex. Vertex implies the point denoted by a point V with two coordinates. We use letter H to represent the x coordinate and K to represent the y coordinate. And nothing gonna surprise in here. Vertex is actually either the top or the bottom of the parabola, those special points that we've been talking before. So let me just rewrite it in here. we have parabola upward or parabola downward. Those 2 points are called the vertex. Okay? So if parabola is open upward, the vertex is the lowest point. And if the parabola is open downward, then the vertex is the highest point on the parabola. Okay? The question is, if you are given a quadratic function, can you find the vertex of that parabola? And of course the answer is yes. So let me just recall the function in general. F of x equals to ax squared plus bx plus c. Then the vertex is calculated this way. We can calculate h, which is the x coordinate, equal to negative b over 2a. And keep in mind that a will never be 0 for quadratic function, so you're okay to divide. Negative b over 2a is going to give you a number, which is the x coordinate, and we denoted by letter h. And then after having h, you can calculate k by plugging that value. This is the x value into the function. So k is equal to f of h, or f of negative b over 2a, because h equals negative b over 2a. Then you have k. You find the 2 coordinates of the vertex. All right? And depends on the sign of letter a, you will know that value k right here is either the maximum or the minimum of the parabola. So let me give you an example. Say f of x equal to x squared minus 4x plus 3. So in this particular example, a is 1, b is negative 4, and c is 3. So a is 1, positive number. We know that the parabola will open upward this way. And then you know that the vertex will be the lowest point on the parabola. We can find the vertex. So apply the formula. H is negative e over 2a. Look at the numbers. Negative of negative 4. Oh, keep it on. This is b equal to negative 4. Okay. So negative of b is negative of negative 4, and over 2 times 1, because a here is 1, which is 4 over 2 equal to 2. After having h ready, you plug into the function to find k. So k is equal to f of 2, which is f of 2 is what? F of 2. This is f of x, so f of 2 is going to be 2 squared minus 4 times 2 plus 3. So let me calculate it quick. 2 squared is 4, minus 8 plus 3. So 4 minus 8 is negative 4 plus 3 is negative 1. So in this particular example, the vertex is at 2 comma negative 1. And this is the point, okay? And you know that this is the lowest point on the parabola. And that means that when you plug in x equal to 2, you will obtain the lowest value of a function, which is negative 1. Negative 1 right here is really the minimum value, the smallest value for the function f of x. Okay? This is the second property about the vertex of the parabola. Next, talking about another property, number 3. I'll be talking about something called the axis of symmetry. Okay, so say just parabola upward, downward is going to be the same thing. This one is out of ink again. So. Axis of symmetry. Parabola upward. You see that the vertex is right here. If you draw the vertical line through the vertex, it's going to kind of split the parabola into 2 halves, the left branch and the right branch, and it's actually symmetrical, meaning what reflect each other from that dotted line right here. And this line, we call it the axis of symmetry. Axis of symmetry. Okay? And the axis of symmetry, the line, the vertical line, will always go through the vertex because the vertex is right the middle point of the parabola. And of course, same thing when you have the open downward parabola. This line is also the axis of symmetry. Okay. Those are the vertical line. The equation of vertical line is what? x equal to something. And you know that what it is? X is going to be equal to h. See why we say h right here? Because this is the vertex. The line goes through the vertex, which is h comma k, right? H comma k. So the x coordinate is always equal to h. So this is the equation, okay? It's not a value. It's an equation of a vertical line. X equal to h, or you can write it x equal to negative e over 2a. Because you know that h is equal to negative e over 2a. So in this particular example right here, this is an open upward parabola. Example right here. And the vertex is at 2 comma negative 1. The equation of this vertical line is x equal to 2. Got 2 right here. Okay. This is the third property of parabola. Let me move on to the next property. Property number 4. Now, I'm going to talk about the domain and the range of the function. Quadratic function, right? So it has a domain and range. Domain and range of the function. Whenever you guys hear the word domain, what do you think of? You should think of the x value, right? The input x, the good value x, or the valid input x. Whenever you think of range, you think of the y value, or the output, okay? So we're gonna study about the domain and the range of function by observation. We're gonna look at the graph. Say in general, I have a parabola, say upward, okay? So of course we learned this point already. This is the vertex, so this is x coordinate equal to h and y coordinate equal to k, okay? Vertex right here, over and upward. This is the x-axis, and this is the y-axis, the origin right here. Domain is what? The x value, right? So you ask yourself, which value you can put the next, like you kind of tracing along the graph and see how the x value gonna vary, so gonna move from left to right. And of course, in this case, we don't have any restriction at all. It means the domain of the x value could be anything from negative infinity to positive infinity. In other words, you can trace along the graph all the way from the very left to the very right. So domain, D stands for domain, okay? So negative infinity to positive infinity, or you can say that all real numbers, okay? What about the range? Now for the range, you don't trace looking left, right anymore. Now you trace along the graph and you're looking up and down. So for the y value, okay? The range for the y value. See that when you trace along the graph, the y value could get up forever. But it's not going to go down forever. How low could it be? The lowest point is the k, okay? So the range is square bracket k all the way to infinity. You guys see why I use a square bracket? Because we're including k as part of the domain. And now you see why k we call the minimum when parabola is open upward. Okay, this is like the domain. I'm sorry, the range. From k all the way up. Alright, so k here really the minimum when the parabola is open upward. Of course, similarly, if you guys have an open downward parabola, then you can figure out the domain and the range as well. Let me make it quick. If you have a parabola open downward, well, this is going to be h here, I'm sorry, h, okay. H here, k there, and domain is still the same as before, from negative infinity to positive infinity, or all real numbers. Negative infinity to positive infinity. And what about the range now? It's not from k to infinity anymore. Now what? It can go down forever up to k. So you're going to write this way. Parenthesis, negative infinity, comma k, square bracket. And this is what we mean. Okay? So all real numbers as negative as small as possible up to k value. And obviously you can see what? k now the maximum value for the function, or this vertex right here is the highest point on the parabola. Okay, so by looking at the graph, you can find domain and the range. You can determine. But I claim that later on, when you guys move on to Calculus 1, we're gonna look at the domain and the range of the function in a more professional way using algebra, not by observation, by looking at the graph. But it's okay for now. Okay, and one more thing, same method you guys can apply to all other functions, not just quadratic function. Okay, by looking at the graph, you basically can determine how the domain and the range of a function look like. Okay, let's move on to another property of quadratic function. Property number 5, the intercepts. Basically, we have two types of intercepts, the x-intercept and the y-intercept, and I guess the name said it all. The x-intercept is a point where the graph intersects the x-axis. The y-intercept is a point where the graph intersects the y-axis. So let me start with the one that I think is the easier one. Start with the first one. How about the y-intercept? Okay, so let me show you guys a graph again. Say upward parabola. This is, draw it better so you guys can see both. Okay, so my graph is right here. I have a parabola. This is my x-axis, and this is the y-axis, and this is a point where the graph intersects the x-axis, the y-axis, so we got the y-intercept right here, and there are 2 points, actually 2 points right there that the graph intersects the x-axis. So in this particular example, we have one y-intercept and then 2 x-intercept. Let's start with the y-intercept. How do you find that point right here, the y-intercept? You see that every point, every y-intercept is going to have one thing in common. Every single point on the y-intercept is going to have the x-coordinate equal to 0, because all the point on the y-axis is going to have the x-coordinate equal to 0. So that gives us a hint. If you want to find the y-intercept, all you have to do is to plug in x equal to 0. Okay, so let x equal to 0, then solve for y. Okay. And by the way, what do we mean y in here? Usually we write as a function. Say f of x equal to ax squared plus bx plus c, right? Y is really the output or the f of x. So instead of writing this way, for graphing purpose, we can write this way. Y out of image n. Y is equal to ax squared plus bx plus c. So y is no more than f of x, okay? And you want to find the y-intercept, all you have to do is plug in x equal to 0. So let x equal to 0. What you got? Y is a times 0 squared plus b times 0 plus c. Obviously, it's equal to c. Okay? So the point right here is a c. The y-coordinate is equal to c. So how do you write the intercept? You're going to write this way. The y-intercept is at 0, comma c in parentheses. It means that the x-coordinate is equal to 0 and the y-coordinate is equal to c. All right? For parabola, guarantee that you always have exactly one y-intercept, because you see right here, you plug in x equals 0, you can always find the value for y. Okay, now let's move on to the other type of intersection, the x-intercept. Second item, x-intercept. Very similar to finding the y-intercept. Now that what? X-intercept is on the x-axis, so what? The y-coordinate is going to be equal to 0, right? So to find the x-intercept, you're going to let y equal to 0, and you solve that. So let y equal to 0, and solve x. Y right here, you let y equal to 0. You have what? 0 is equal to ax squared plus bx plus c. How do you solve for x from here? You guys recognize this one? We call it the quadratic equation. Okay, what we have right here is called the quadratic function with output y and input x. Right now we don't have y, and we plug y equal to 0. You actually have an equation, and this type of equation we call it the quadratic equation. And we do have a very famous formula to solve a quadratic equation, which is called the quadratic formula. And I bet you all still remember the quadratic formula. Quadratic formula say what? X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And let me box the formula for you. Okay, one more time. The quadratic formula says this. If you have a quadratic equation ax squared plus bx plus c equal to 0, then you can always solve for x using the formula. X will be equal to negative b plus or minus a radical square root of b squared minus 4ac all over 2a. And unlike the y-intercept, you always have exactly one y-intercept. For the x-intercept, you may have a couple cases to look at. Okay, let me show you the cases for the x-intercept. And I'm showing you the example of upward parabola, but I am claiming that it's going to be very similar. It's the same way for the downward parabola. Okay, if parabola is completely above the x-axis like this, you guys obviously have one y-intercept, but no x-intercept. Okay, and now think of shifting the graph down a little until it touches the x-axis, and you're going to have exactly one x-intercept. And you know what that point is? It is the vertex. Similarly, if you kind of shift the graph a little bit lower, now what? It's going to intersect the x-intercept with 2 points, and you have two x-intercepts. So three cases: no x-intercept, one x-intercept, and two x-intercept. Okay. Again, always have exactly one y-intercept. Keep extending that range. Eventually, it's going to intersect the y-axis for sure. Okay. So how do you know? It depends on the square root rather than the radicals right there. And by the way, actually we have a name for it. The quantity right here called the discriminant, I think. Make an asterisk. Discriminant, denoted by delta, is equal to b squared minus 4ac. Okay? You see that that quantity is under radical square root. So if that quantity is a positive number, so delta is a positive number, say 9, then you have square root of 9. With plus or minus, you're going to have two values, plus 3 or minus 3, right? Which indicates you have two solutions or two x-intercept, two x-intercept. Okay? What if delta is equal to 0? Say square root of 0. Doesn't matter, you put plus or minus in front, square root of 0 is 0, plus or minus 0 is still 0. You have exactly one solution. You have one x-intercept. Okay? What if delta is a negative number? Say square root of negative 4. Now you don't have a real solution anymore. Actually, square root of negative 4 equals 2i. And you have an imaginary number. So no real solution means what? No x-intercept. 0 x-intercept. Okay? So far, so good. And in many cases, you guys can be lucky. It means that you don't even need to use a quadratic formula. You can actually like factor it out, and then you can have the solution. Let me give you an example. Let me use the same example I gave you before. F of x equal to x squared minus 4x plus 3. Now you want to find the x-intercept. Let y of f of x equals 0, right? And I claim that this one can be factored out, plus 3. This can be factored out. It's going to be x minus 1 times x minus 3 product of two factors equal to 0, either x minus 1 equal to 0, x minus 2 equals 0, x minus 1 equal to 0, or x minus 3 equal to 0. It means x equal to 1 or x equal to 3. So you guys are going to have two x-intercepts, all right? And two x-intercepts are what? 1 comma 0. This one is going to be 3 comma 0, right? And you don't even have to use the quadratic formula at all because we're just lucky this time. Actually, I'll say it this way: if you are having nice enough coefficients, the numbers 1, negative 4, 3, then you can actually just need to factor the quadratic function out, and you can find the solution without using the quadratic formula. But this is more powerful. Means what? Doesn't matter what kind of number you have. Doesn't matter if it's nice enough. You just plug in the formula. For sure, you have a solution. Just make sure that you guys be very careful with your algebra, so don't make any algebraic mistakes. You should be fine. You should be fine. Okay. All right. So actually, we just pretty much going through some review about quadratic function. Let me extend the concept a little bit more. Let me show you another type of quadratic function that you may see, and actually it's pretty helpful. Like the linear function, you may have several ways, different ways to represent a linear function, like what? Slope-intercept, or what? Point-slope equation, or what? General equation, and same thing for quadratic. So far we learned this. F of x equal to ax squared plus bx plus c, right? We use this form to define quadratic function, and this is called the general form. Okay? Now I'm going to show you another form. This one. Right, this way. F of x equal to a times x minus h squared plus k. I usually call it the vertex form. You see why? H came here. We learned that before. But actually it have a formula for it called the standard form. Standard form. Okay? So if you write the quadratic function this way, we're going to call it the standard form of quadratic function. It's another way of writing quadratic function. All right? Example. If I have f of x is equal to example, right? So about 3 times x minus 1 squared plus 4. And you know what that a is? This is the same a as the upper one here, means the leading coefficient. So here in this example, a is equal to 3. And a is 3, a positive number. And what does it tell you about the graph of this quadratic function? It's a parabola that opens upward. Okay? And here, minus h corresponding to minus 1. It means that h is equal to 1. Plus k corresponds to plus 4. So k is equal to 4. Tell you what? The vertex in here, right? Vertex is what? 1 comma 4. Okay? So this one, you see this one right here? You know the orientation of parabola, and you also know the vertex right away without doing much work at all. All right? So one of the things that you guys gonna need to know to do your homework is what? How do you convert back and forth between the standard form and the general form? So I have this standard form. Standard. Just write the whole thing down, right? Standard. And this is the general form. Standard form is what? 3 times x minus 1 squared plus 4. You want to bring it back to the general form, what do? Factor this out. That's all you need to do in combined line terms. So this is what? 3 times x minus 1 times x minus 1 and plus 4, right? And what I think that many of you guys learn call it what? FOIL, I think. X times x times negative 1 times x, and then negative 1 times negative 1, 3 outside, right? X times x is x squared.